Domains get resolved into IP addresses. Routing is all based on IP addresses. So by and large, you can go to an IP address and get to a website. The details are that lots of websites like WordPress.com actually have just one IP address for millions of different web pages. And the way they figure out which web page you're actually talking to, as opposed to the default, is by actually looking at the domain name itself. So if you have some domain name like tomshardware.wordpress.com and you just go to the IP address, you're going to get the WordPress.com default page as opposed to Tom's Hardware page. This allows somebody that is hosting lots of different sites to map all those sites to a single IP address, which is where their servers are, and share servers across many, many addresses. This is called name resolution. It works for both HTTP and HTTPS. Other protocols like SSH do not have name resolution. They don't have the capability of doing that. But lots of web page type protocols and web servers use this technique for resolving names. There are a bunch of special IP addresses. The reason for these special IP addresses varies, but the first one of those that you need to know about is a thing called localhost. That is the address that your computer uses to talk to itself. And localhost has lots of applications, like you're building some piece of web software and you want to run a server on your system, but then you want to talk to that server on your local system. This is probably the most common way to go about testing. We're going to refer to localhost. I have the IP version 4 address here. Later, when we look at IP6, we're also going to see that there's an IP version 6 address. There are 3 commonly used subclasses of addresses. And what happens is there's a finite number of addresses out there in IP version 4. It's a 32-bit number, so there's billions, but they all got used up. So what they wanted to do is they wanted to have businesses and other large institutions have a single address and then take all of their computers inside that and do this network address translation where their local computers had a series of addresses, but then a network address translator would take those addresses and remap them for the outside world. So they created these subclasses, class A, B, and C of addresses. The University of Wyoming uses a class A internally, which starts with 10 dot, and that has 24 bits of potential addresses inside the University of Wyoming. Lots and lots of ISPs, when you set stuff up, they will give you a class B address that is your address that you use inside your local system. And it has 65,000 addresses that are available to use. And a Class C address is the most common for small routers like a home router, where you have, it's more than just 256, which would be that last octet of addresses. But most people will use 192.168.0 or 192.168.1. That 0 there can also be set to other values. So it's bigger than just 256, but most people are using just 256. So IP version 4 ran out of addresses that could be assigned. We knew this for years in advance, and consequently they developed a standard called IP version 6. I have no clue what happened to IP version 5. I don't think it was a real thing. So IP version 6 uses a much bigger address. And it's in hexadecimal, and I gave you an example there of 2001 dBA. Each one of those is a 16-bit value, so I think it has 2 to the 128th addresses, which is enough to give a IP version address to every subatomic particle in the known universe. So they're not going to run out. At least not anytime soon. Localhost looks like ::1. When you see a : in an IP version 6 address, that means that they're leaving out zeros in the middle of the addresses. So if you refer to your localhost in an IP version 6 fashion, it looks like http:// and then they put in square brackets, : square brackets for the address of localhost on your system. Most Macintoshes and recent versions of Linux by default use IP version 6. So it today represents probably 30 to 40% of all addresses that are used in the world today. And it'll only switch to a version 4, like 127.0.0.1, if the IP version 6 address is unavailable or not used. So the preference is for the new addresses. There are lots of nice things about the new addresses, and they're developed 30 years later than the old address system, and consequently they have lots of good features, and there's lots of reasons to use it. But there are still a lot of things that are using the old addresses. There's old hardware, there's old systems, and it's a heck of a lot easier to type in an old address than a new address. Basically, the new addresses are big enough that you're going to cut and paste them. You're not going to type them in. Whereas there are addresses that I just know for certain things that are out there in IP version 4. It's unlikely I'm going to memorize one that's that big. So, things to remember about this. www.2cy.com and 2cy.com actually have different addresses. You can assign them. There are addresses for your local system. You can usually refer to things by their address. They don't have to have a domain name. This is like calling a friend's number where you know it's, 745-3138 because you remember their phone number as opposed to looking up their name in your address book and calling their name. But there are plenty of things that you can't get to without still providing the name. So you can also have other domain names that you might want to test with. For instance, test1.2cy.com and mike.test1.2cy.com, each with its own address. And you can point these addresses back at your own computer. The way that you do that, the easiest way to do that, is on Linux and Mac systems, there is a /etc host file that gets looked up for addresses. On Windows, it is Windows System 32 EDC host usually, or search your system for a host file. And the host file is a text file. You can edit it with a standard text editor. It has addresses and names in it in a fairly obvious format and usually a comment at the top explaining how you can change it and edit it. One way to do ad blocking is to put a whole bunch of addresses for all the ad servers out there in the etc host file and redirect them back to your own computer. And suddenly, all these ads that normally pop up in your web pages will end up going back to your own computer. Now, what happens when somebody, not necessarily malicious, but intentionally spoofs the wrong addresses and sends them to some other location? You can do this. For instance, you might want to spoof a.doubleclick.com, one of the major ad sites. It's owned by Google, but it serves about 20% of all the ads across the web, off to some other address, like 127.0.0.1. Or you might want to do this in a less friendly fashion, but suddenly you can replace that name with a different server. There are systems that help prevent this. DNSSEC is a system that helps prevent this. It's a security layer on top of DNS. And there's also DNS over HTTPS, a new thing that they're putting into a lot of the browsers to help prevent this. Another thing that you can do is you can use as your domain name resolver some server that doesn't change. Mostly in your setup, you can change these things to some sort of a name server that you trust. For instance, CloudFront, which is a web caching company, has 1.1.1.1 or 1.1.1.2 servers, depending on whether or not you like blocking of porn sites. The .2 is blocks porn sites. And Google runs a couple servers too with those addresses 8888 or 8844. I tend to use those for most of my setups so that somebody can't come in and say, oh, I'd really like you to see my ads instead of somebody else's ads. This seeing somebody else's ads is really a common thing. If you have a laptop and you connect to a wireless network, part of that connection is usually a thing called DHCP. So your computer doesn't have an address that it uses all the time. It has one of these network address translated addresses that needs to be set on a per network basis. So your computer gets an address from the server. It says, go out to the local server, give me an address, give me my DNS setup. I'll set those up while I'm talking to you. That's a pretty common way of doing things. It means that your address can change on your local setup, and certainly when you take your laptop and connect to the University of Wyoming system, that's how it works. Your home system probably works this way too. And you have a temporary lease for how long you get to have that IP address. Leases can vary anywhere from a few minutes to years, depending on how your local server is set up. So let's say you're in DIA, the airport, and you connect to AT&T's Wi-Fi hotspot. So it gets this set up and sets up your laptop. All is well. Suddenly you're working and you browse some page like the Washington Post. Now, instead of a.doubleclick.com and sending you to the correct address, these things tend to do nasty stuff under the covers, like redirect that to AT&T's advertising site so that they can get the revenue from the ads instead of DoubleClick and Google getting the revenue from the ads. And this is not a theoretical example. This actually happens all the time. This is one of the reasons why you would want to use a VPN when you connect across somebody's Wi-Fi network, because what the VPN provides you with is it encrypts all of the traffic coming from your computer out to some server on the web so that somebody in the middle isn't watching your computer, listening to all the things that you type, deciphering them in the middle, and gaining things like adding tracking to your computer, replacing ads, changing what the content is on pages. So the VPN prevents man-in-the-middle attacks. It doesn't provide you with anonymity, as in, you can't guarantee that the VPN isn't going to turn over their logs of who you are and when you were connected to somebody else, or sell that information. And lots of VPNs, like even the big ones like NordVPN, have logging. There are ones that don't. But what it does prevent is it prevents somebody with a malicious Wi-Fi from listening in on what your traffic is. So it prevents man-in-the-middle attacks.